Okay, so in this video, we're going to be talking about solving multi-step equations. Now, I already did videos on one-step and two-step equations, so I highly recommend that you watch those videos before trying these problems. I'll go ahead and link them both in the description box below so that you can have access to that content. And so assuming that you already know how to do one and two-step equations, let's go right into these problems. Now, before we start going into these problems, I just want you to take a look down here, and these are going to be the inverse properties. And again, you probably already know this, but the opposite of addition is going to be subtraction, and the opposite of multiplication is going to be division. And again, that is vice versa. You can go in reverse, right? So the opposite of subtraction would be addition, and the opposite of division will be multiplication. You're going to have to know that in order to do these problems, and you probably already do. So if we look at number one, what do we need to do first? Well, remember the goal. The goal is to isolate x. That's what we want to do. So if you're ever confused on what operation that you need to do, you can just do PEMDAS in reverse. So you guys all remember PEMDAS. So if I have PEMDAS, that's order of operations, right? And again, we typically do this when we're simplifying down expressions, right? But you can actually use it for equations, and you actually go in reverse. So if you're confused on what to do first on number one, do PEMDAS in reverse, and you see that you have addition and subtraction. So if you go left to right on this problem, you're looking for either addition or subtraction. I'm going left to right now. Right here, I have addition, but I don't want to do that because it is in parentheses, okay? And if you look at your order of operations here, if we're going in reverse, our parentheses is going to be one of the last things that we do, okay? So I don't want to do that right now. But this negative 10 is all alone, and that is what I'm going to end up doing first. So the opposite of a negative 10 or a minus 10 is going to be positive 10. So that's going to be my first move. Now again, over time, you probably are not going to need to use this, okay? Once you get good at these equations, it's going to be like second nature to you, and you won't even have to really refer to this. But it's a good tool to refer to if you're ever confused, okay? So let's do number one, and then we'll make our way through these problems. So our first step is to add 10. So we're going to add 10 on both sides, okay? This will cancel. I'm going to bring down 2 and then x plus 2, okay? And then equal to 30. So at this point here, you actually have two options, okay? You can take this 2 and you can go ahead and distribute inside. That's totally fine. But actually, an easier way to do the problem would be to divide this whole thing by 2. Because it's multiplication here, okay? And the opposite of multiplication is division. This method right here that I'm showing you is going to be the path of least resistance. It's going to be the least amount of work. And I like doing the least amount of work, and I think you probably do too. So if you're not comfortable with doing this way, that's fine. Just go ahead and distribute the 2. But there is going to be more steps involved in that method. So that's why I prefer this method right here. So this will cancel right here. Remember, it always cancels out where you do the operation first. That will always happen. And then I do have to balance it out, so I divide here by 2. Okay, so now I'm going to bring down x plus 2. And then I have equal to 30 divided by 2 is 15. Okay, my last step, minus 2. And we pretty much have the answer now, right? So I'm going to do 15 minus 2, I get 13. X is equal to 13. And that's it. Okay. Now remember, you can do a mental check, plug it back into the original, and does it equal out? So if I plug a 13 into x, what do I get? I get 13 plus 2, that gives me 15. And then 15 times 2 will give me 30. And then minus 10, I get 20. That does check out. So we did it correct, okay? So if this did not check out, you'd have to go back and resolve the equation and check your work, okay? But we're good there. Let's try 2. I'm going to rewrite the problem. So it's 2 over 3. And we actually do not have to put this fraction in parentheses here. We can drop the parentheses if we would like. I'm going to go ahead and drop them. And then I have x plus 5 in parentheses, okay? And then minus 2 equal to 12. So in this problem here, our first step, we're going to want to get rid of this negative 2 or minus 2, right? So I'm going to add 2 on both sides. Okay, this will cancel. Bring down this fraction 2/3. Then we have x plus 5 equal to, and again, this canceled here, and now we have 12 plus 2. That will give us 14, so equal to 14. Now from here, again, you have two options. You could go ahead and distribute this inside, right? But if you do that, look what happens. You're going to end up with a fraction. You're going to have 2/3 x. And then you're going to have another fraction, which is going to be 10/3, which I really don't want to deal with, okay? So an easier way to do it, to get rid of this fraction here, we're just going to multiply by its reciprocal, okay? And the reciprocal of 2/3 is going to be 3/2. Now, when we do this, this is actually called the multiplicative inverse because it's going to end up equaling 1. So the multiplicative inverse is when you take a number and you multiply it by its reciprocal, the result will always be 1. So what ends up happening here, this will cancel, this will cancel, this will cancel, this will cancel. I'm left with 1, right? I cancel it out. But I also have to do it on this side here. So I'm going to multiply by 3/2. And we can actually cross-reduce here. Remember, this 14 right here is over 1. So I can cross-reduce. 2 goes into itself 1 time. 2 goes into 14 7 times. So what am I doing? I'm doing 7 times 3, which is 21, all divided by 1. So 21, right? So I'm going to rewrite it. I get x plus 5 equal to 21. My last step, I have to minus 5 on both sides. So what do I get when I do that? I'm going to get 21 minus 5, and I end up with 16. So I'm going to write here x is equal to 16. And that's going to be the final answer. So we should check it. Okay, so we're going to plug it back in. And hey, maybe we need to use a calculator here, or maybe you can do it in your head. But we're going to do 16 plus 5. That will give us 21. Okay, now we have this fraction here that we have to multiply by. So I'm going to do 21 times 2, and that gives me 42. And then 42 divided by 3, I end up with 14. And then 14 minus 2, I do get the 12, so it does check out. We did it correct. Okay? Okay, let's try some more problems. Okay, so here's our next set of problems. I have x over 5. So we're doing number 3 right now, x over 5. And again, you can drop the parentheses here if you would like. You don't really need them. So I'm going to leave it like that. And then plus 3 times 7 over 3. Okay, equal to 10. So this one actually works out pretty nice because look what happens with my fraction here. These 3's are actually going to cancel out. I'm going to be left with just 7 there. So now I have x over 5. X over 5 plus 7 all equal to 10, right? And so from here, it's really just a two-step equation. I have this positive 7. I'm going to minus 7. So I do that on both sides, right? Cancels here. Bring down x over 5. Equal to 10 minus 7 will give me 3. And then from here, you're going to want to multiply both sides by 5 because I have division here. So how do I get rid of division? I multiply. What am I trying to get rid of? I'm trying to get rid of the 5, right? I want to isolate the x. So I'm going to multiply both sides by 5. And this problem is now going to be done. So this will cancel. I get x is equal to 3 times 5, which is 15. So let's go ahead and check it. If I plug it in here, 15 divided by 5 is going to give you 3, right? And then plus, well, what happens here? Remember, the 3's do cancel. So I'm left with 3 plus 7, which is in fact 10. So that checks out, okay? Let's try number 4. I have 7 over x. So the same thing, you can go ahead and drop those parentheses. You do not need them. You can leave them there if you would like, but you really don't need them. And then minus 2 times 10 equal to negative 27. So what do I do here? Well, is there anything I can combine here? I have a negative 2 times 10. I can go ahead and simplify that down. It's going to give me negative 20. So I'm going to write 7 over x minus 20 equal to negative 27. Okay, what do we do from here? Well, look, I have subtraction. I'm going to do the opposite, which is addition. So add 20. So adding 20. And so we're going to end up with a negative number here. This will cancel. I bring down 7 over x equal to negative 27 plus 20 will give you negative 7. And so what essentially is going to happen here, this x and this negative 7 are going to end up switching places, okay? And you'll see how that's going to work out. Because essentially what's happening here, you have a proportion right now. And so if you're having trouble visualizing how that's going to work out, I'm going to show you right now. So hopefully it will make it a little more clear. So let me go ahead and do this in a different color. Off to the side here, okay, let's kind of just box this in so we know we're working on a different problem. I have 7 over x equal to negative 7 all over 1. That's what's really going on there. This negative 7 is really over 1. So if you wanted to solve this, again, you have a proportion. If you have 2 fractions equal to each other, you simply cross multiply. That is a proportion, right? 2 ratios equal to each other. So I'm going to cross multiply here. 7 times 1, and then I'm going to do x times a negative 7. Okay? What do you end up with? Well, 7 times 1 is 7. Equal to x times a negative 7 will give me negative 7x. Okay? And my last step here, I have to isolate x. I have multiplication here. It's negative 7 times x. I divide both sides by negative 7. Okay? And so you can see here what I was talking about. They switch places. Here's my x, and here's the negative 7. That's what I was talking about right here. Okay? And so what ends up happening? You do 7 divided by a negative 7, and you get negative 1. So we're just going to put here x equal to negative 1. That is going to be our final answer. Okay? Now we can go ahead and check it. So right here, if I plug it into x, 7 divided by a negative 1 is negative 7. Okay? And then we know that this part right here will give us negative 20. Okay? So it's a negative 7 and a negative 20. That will give you negative 27. All right? So that problem's done. All right, let's try one more problem, and it's actually a bonus problem. So let's go ahead and take a look at that. Okay, so here's the bonus problem, and it's a little bit longer than the others, but I think we can work our way through it. So on this problem here, typically when we had this set up, we had like a number on the outside of these parentheses. We divided it out. But to be honest with you, that's probably not the best course of action here, just because I have a lot going on here. So what I'm going to do here, I'm just going to take this 4, and I'm going to go ahead and distribute inside. And the same thing with the negative 5, we're going to go ahead and distribute inside. And so what we end up with is 4x, and then plus 8, okay? And then right here we get negative 10x. And then, well, what happens here? The 5s actually end up canceling out, right? I have it both on the top and the bottom. The 5s will cancel, but I do have this negative here. So I still have a negative. It's going to be negative 1 equal to 25. From here, it's just combine like terms and solve. So my like terms are right here and here, and also here and here. So I'm going to go ahead and combine 4x and a negative 10x. That would give me negative 6x. So I like to cross them out so I know that I'm done. Okay. And right here, I do 8 minus 1. I get plus 7. Okay. All equal to 25. Okay, what do we do from here? Well, I have to minus 7, right? Just like we were doing before. Okay, this will cancel. Here I get negative 6x equal to 25 minus 7. I'm going to get positive 18 there. So positive 18. And now my last step, I have to get rid of this negative 6. It's negative 6 times x. So I have to do the opposite, which is division. And I'm not just going to divide by 6. I want to get rid of the negative 2. So I'm going to divide by a negative 6. That's important. You want that entire number gone, not just the 6. So I'm going to divide here by negative 6 as well. This will cancel. 18 divided by a negative 6 will give you negative 3. So x is equal to negative 3. All right, so let's go ahead and check it. How do we check it? We're going to plug it right back in wherever we see an x. So let's go ahead and do that. I'm going to write it in a different color. This one we're definitely going to want to write out. So I'm going to have 4 times, and we can do this part in our head. We have a negative 3 plus 2. That gives me negative 1. So I'm just going to put negative 1 here. And then minus 5 times. Now 2 times a negative 3 will give me negative 6, right? So you end up with negative 6 plus 1/5. So from here, we're going to do 4 times the negative 1, we get negative 4. And then don't freak out about this fraction here, because what we're going to end up doing, we're going to distribute this negative 5 to both the negative 6 and the 1/5 there. So negative 5 times negative 6 will give you positive 30, so plus 30. And then negative 5 times a 1/5 will give you negative 1, right? The 5's cancel, and I'm still left with that negative though, so negative 1. And now what happens? Well, negative 4 plus 30 will give you positive 26, and then 26 minus 1 will give you 25, right? So this one does check out, and so we just did a quick mental check there just to prove it out. So that is multi-step equations. I hope that you found the video helpful and that you gained something from it. If so, could you please just go ahead and give this video a thumbs up? That would be greatly appreciated. And also make sure you subscribe so you get more math videos in the future, and I'll see you in the next one.